Yes, I'll start the recording as well. So sorry. Yes, so I bring forward to you one of such amazing sessions that we are going to conduct. The first session is Intro to Building on the Internet Computer, hosted by Dominic Wörner, who is a senior solutions architect at Dfinity, and he's going to take us through this event, this workshop, and going to teach us about the fundamentals of this Internet Computer blockchain and the tools and resources that you can use to build your project in the Build for Web3 hackathon, and also some resources that he might share with you guys. So very, very excited. But before we begin, if you have not already, this is the registration form for the hackathon. So if you've not yet registered, you can scan the QR code. I'm going to keep it on the screen for a minute. You can scan the QR code and register for the workshop, and also register for the hackathon in the meanwhile. I'm still letting in a lot of people inside the from the waiting room inside. So if you're just joining, scan the QR code. If you have not already registered, make sure that you do register in the hackathon. Hello, everyone. Hello, everyone in the chat. Hi, Navneet. Hi, Abdul. So good to see you guys. All right. For any other updates related to the hackathon, if you've not already joined, this is the QR code for the Lumos Metaverse Discord server. All the updates, all the small regular updates related to the hackathon, all the resources, all the mentors of our hackathon would be on the server. So if you've not joined already, make sure that you do scan the QR code and become a part of the server. Make sure you verify yourself, give yourself the hackathon participant role so that you receive all the important updates related to the hackathon. I'm still going to keep it on the screen for a few more moments before Dominic takes over and we start the session. Hello, Swaroop. So throughout the session, if you have any other questions for Dominic, if you need, you can ask the questions in the chat section. We'll try to address them in the end of the session if the time permits. With that, I'll stop sharing my screen, and Dominic, all over to you. Let's get started with the session.
So thank you, Nikhil. Can you see the presentation now?
Yes.
Awesome. So hello, everybody. I'm really excited to be here to talk a bit about the internet computer, what it is, and how you can use it to build something cool. So I want you to learn today what's the internet computer, what the internet computer is capable of, and I want to also present a bit about the technology behind the internet computer. And after that, we dive into how you can program the internet computer with Motoko, which is a programming language that is built for the internet computer. And after that, I hope to answer at least some of your questions that you'll have. So let's dive right in. What is the internet computer? So the internet computer is a scalable platform that allows you to run any kind of computation using blockchain technology for decentralization and security. So you might know other blockchain platforms where you can run some limited smart contracts, which are then part of the backend of your stack. But the idea of the internet computer is that you're able to run full stack apps or decentralized applications on chain. There are a few things included in the internet computer that allow you as a developer to build these programs, deploy them on the internet computer, and regular users can just interact them with their web browser. So in the internet computer, you have what we call the reverse gas model. So you as a developer, as a starting point, you will load your smart contract essentially with some cycles to pay for computation on the internet computer. But this allows then your end users, to interact with the with those applications without the tedious requirement to set up a wallet and get cryptocurrency to start interacting with your decentralized application. Although, of course, if your application requires that your user pays something in some kind of cryptocurrencies, you can do that as well, of course. So besides running full stack dApps on the internet computer, there are some additional features that are pretty cool. So the internet computer allows to orchestrate the bigger Web3 ecosystem. And what that means is that smart contracts on the internet computer can sign transactions destined on other blockchains. You're able to sign Ethereum transactions or Polygon transaction and build like a meta layer application on the internet computer. Besides that, we are currently rolling out the native Bitcoin integration, which uses this threshold ECDSA feature to sign Bitcoin transactions, but furthermore allows to access Bitcoin liquidity on the internet computer. So applications that you write on the internet computer will be able to access the current state of the Bitcoin system, so the UTXO set, such that your DeFi applications you might want to build on the internet computer can access Bitcoin liquidity directly. Another novel thing for blockchain technology is that smart contracts on the internet computer can do HTTP calls. So you might know from other platforms that you need oracles to get data from outside the blockchain platform inside your smart contracts. On the internet computer, you can do it with oracles, but additionally, you can basically have the system fetch the data from external web APIs like trading data or weather data or whatever you like. And also you can do post requests to trigger actions. So for example, send an email from within your blockchain application, or send an SMS message or something like that. There's a lot you can do with this feature. So now that we know a little bit of what you can, like from a high level point of view, what you can expect from the internet computer as a platform for your decentralized applications, I want to dive in a bit deeper. What's the technology behind it? So the internet computer can be understood as basically a lot of blockchains. So the internet computer can scale by adding additional subnets. And each subnet is a replicated state machine. That means it is a blockchain. And canisters, which are the applications or the smart contracts on the internet computer, are living on different subnets, but they can interact with each other. There's no difference from a developer point of view if this canister is sitting right next to you on the same subnet, or it's in a different subnet. There's additional latency latencycycycy of course, but from a programming standpoint, there is no difference. And one of these subnets, the first subnet that came into existence, like in early to mid last year, is the subnet that hosts the network nervous system. And the network nervous system is essentially a DAO that governs the internet computer via liquid democracy. And this allows the internet computer to be a system that allows rapid evolution. So we have regular software updates essentially of the internet computer itself, typically on a basis of every week. And each new update goes through this governance process where ICP holders, this is the native token on the internet computer, can lock up ICP for a specific time frame, and based on how much they lock up and for how long, they have what is called a neuron in this network system with voting power, depending on how much and how long, to participate in these governance resolutions. So this is also very different from other blockchain platforms, where you typically have software updates maybe every few months, if at all. So the internet computer can upgrade itself on a regular, fast-paced basis. And the technology that allows scaling and allows also lightweight clients, this means that you can interact, for example, from your browser with applications on the internet computer. It's called chain key cryptography. So a client that wants to do something on the internet computer and wants to be sure about the outcome of its computation only needs to have a constant 48-byte public key. And chain key cryptography is based on threshold signatures. So the nodes in each of those subnets, in each consensus round, they come together to form a signature that certifies the current state of this blockchain. And the NNS subnet, the main subnet, certifies basically the keys of every other subnet. And so this means each subnet, so each canister smart contract on a specific subnet, if it gets a message from another subnet, he will check a delegation. So basically every subnet only needs to know this one public key of the NNS subnet, and also every user or every software that wants to interact with the internet computer also only needs to know this one public key to verify essentially to verify the state of the current system. So very different from the typical blockchain, where you have to keep track of all the blocks of the entire history. And there's a lot more to learn about that. So I've included a link in here, and I hope to share the presentation afterwards, that it's easy to follow all these links. There will be quite a few more. So I've mentioned it already quite a few times. The smart contracts that you can deploy on the internet computer are called canisters. And they are essentially a WebAssembly bytecode plus attached data. So code plus memory pages. And what's pretty cool about WebAssembly, it's a low-level virtual machine and instruction code, which runs very close to the actual hardware. So it's blazingly fast. And there's many programming languages can be compiled down to WebAssembly. So in principle, it's possible to write your canister smart contracts in all kinds of different programming languages, but the tooling is not there yet. So what you see here, these are basically the programming languages you would use today to build canister smart contracts. So one is Motoko, which, as I mentioned earlier, is a programming language that is purposely built for the internet computer environment, and we'll come to that in detail and a little further. And then a lot of the more complex applications on the internet computer are built with Rust. It's because Rust is like gives you reasonably a low-level interface, but it has a huge ecosystem of libraries and things like that. And most of the libraries you can just use on the IC. A newer development from the community is the possibility to write your canisters in TypeScript. And as I said, it's pretty new, but a lot of developers already find this very, very useful. So typically, when you hear about smart contracts, then they are immutable. On the internet computer, the smart contracts are upgradable by default. You can specify controllers of a smart contract, and a controller can upgrade it. You can also remove all controllers. Then your canister is immutable. And a lot of work went recently, like from Dfinity, but also from other companies, to develop essentially DAO canisters that can govern the upgradability of a canister. So similar as the network nervous system governs the upgradability of the whole internet computer, that there are mechanisms in the working that allows to application developers to decentralize their applications and also govern the upgrade process of their canister smart contracts through similar mechanisms. Canister smart contracts are implemented in the actor model. This means they can run asynchronously and can therefore run in parallel. So this is also very different from other blockchain platforms where you have synchronous execution environments, where each new transaction needs to the whole call needs to execute at once. In a canister smart contract, when you run applications inside one canister, then it's also synchronous, but you can open up the synchronicity when you call other canisters. Then your canister state will be suspended, and later when you get a return, it will run further, but it doesn't stop the execution of the same canister code or other canisters in the same time. And this is also one of the basis of the performance and scalability of the internet computer and the applications running on top of it. The other difference I also mentioned before, canister smart contracts consume cycles for computation and also for storage, so to really pay for the resources they use. And users interacting with it don't necessarily need to pay, but of course you as a developer can define that special calls to a canister incur costs to the caller. Okay, so let's now dive a bit deeper into Motoko. As I said, Motoko is a general purpose programming language that is specifically designed to work on the internet computer. It follows the actor model, but it also supports async await syntax to make it easier for developers to program these multi-canister applications, essentially. It also has automatic integration with Candid, and I will talk about that a bit later. Candid is the interface description language that is used on the internet computer. So how you define your public interface, how other canisters and other applications can call your canisters. Then another cool feature of the internet computer is orthogonal persistence. So on all these different machines that your canister is running, you don't need to take care about putting data in a database or whatever, but the state lives always at your code, and when you call or when your canister is called at different times, it always has this data at hand.
Hey,
the only
Dominic, there is a question in the chat that is kind of related to what we're speaking. Someone has asked the question, if you could explain us the actor model in a brief. What is the actor model? If you could explain it shortly.
Yeah, the actor model is a programming paradigm that you have. It's a bit like object-oriented programming in a sense. It
Understood.
means you have the actor is a thing that has state, and it can only interact with other actors by sending messages to the other actors, and only those messages then can change the state of the actor. And this is a model that was especially theorized to provide safe concurrent programming. So in a model where you have asynchronous programming, where many things run in parallel, you always have the problem about handling state in this scenario. And the actor model is an approach to do that safely. But we weaken it a little bit with the async await support, because it's just much easier to write applications using async await, which are used for many other programming languages. So you can use the raw actor model, but many developers will use async await.
Got it. I think there's also a question related to, makes sense completely. There's also a question in the chat related to whether Rust or Motoko, which one will be better for coding in ICT?
Yeah, it depends a bit. So Motoko is a quite new language. So if you know Rust, you would need to learn Motoko, and there are not that many libraries out there because it's a new and young ecosystem. But it's very elegant to write programs on the IC with Motoko, because all the cool features of the IC are seamlessly integrated into Motoko. So I think if you're interested in the internet computer and interested in this whole new paradigm, then it's nice to at least play around a bit with Motoko. What we've seen is when applications get really large and complicated, then many people switch to Rust just because a lot of tooling and libraries is available off the shelf, and they can just use it instead of implementing low-level libraries. For example, I don't know, to do JSON or CBOR decoding and encoding and all these kind of things. It's cool to have Serde, if you know Rust a bit, to do all these kind of serialization and deserialization work, and you don't have to care about it.
Understood. Totally makes sense. I think we can move forward. The rest of the questions are general in nature, so I think we can take those in the end of it.
Okay, cool. Yeah. So one of the things that are pretty cool and abstracted away in Motoko. So I said canister smart contracts are upgradable by default, but it's not that straightforward and simple to what happens to your state, to all the data in your canister when you upgrade it. Will that be compatible? What should happen? So normally, if your normal state would basically erase when you upgrade. So you're starting with a blank slate, and we will, if we come to it, we will see that in an example later. But in Motoko, you have this cool feature that native data types and some of the more advanced data types, you can annotate them with the stable keyword, and then the system or the Motoko runtime translate that away for you. So when you upgrade your canister, all the state will be serialized and your canister will be upgraded, and afterwards your data will again be deserialized. And for example, in Rust, you have to do these steps manually. And then it's basically the same in Rust with the SDK we provide. And in Motoko, you of course have access to all those cool IC mechanisms, such as handling, sending cycles to other canisters, do these upgrades. And there's also a feature that's not available in most of the blockchain platforms, as I know. So typically, you need to somehow trigger a smart contract from the outside. So you as a user or a system sends a transaction to the smart contract, and then it does something. On the internet computer, you have a mechanism called Heartbeat, which basically allows to specify that your canister is triggered by the runtime. So the nodes themselves trigger your canister periodically, and you can then decide if you want to act on something or not. It's a bit like a cron job that can be run. Yeah, I mean, I've talked about that already. Yeah. An actor is an autonomous object that fully encapsulates its state and communicates with other actors only through asynchronous messages. There is a pretty cool video on YouTube of the inventor of the actor model and some other folks that really goes, it's like a whiteboard session that goes in detail on that. So I suggest of anyone who's really interested into the actor model to watch that video. Then I touched on that a bit. So on the internet computer, you have Candid, which is an interface description language and allows to specify how the interface of your canister looks like. So how do you get called from other canisters, and also from programs outside the internet computer. And here on the right side, we see how that translates. So if you have a Motoko actor with different functions, services that are available from the outside, this has a specific Candid representation. And Motoko does that all under the hood for you. and we can automatically create bindings for languages like TypeScript, and there will be additional automatic tooling around it and we will see that later, how you get automatically bindings created for all those canisters that you implement. And in Rust, for example, there's a mechanism to create those candid descriptions also automatically, but it's not that seamless as in Motoko, and many people will manually like adjust the candid representation of their Rust canisters. Yeah, I've touched on that also. Yeah, although Motoko supports the actor model, it's still possible to have this nice sequential programming model with async await. So every time you write await in your code, what's basically happens, your canister is getting suspended from the current execution, and the system can do all kinds of other things, and it makes a call to another canister or itself, and at some point later there is a callback coming back from the other canister with a reply, basically, and then it gets in another block, basically, gets back into execution state, and this reply is handled, and you will be in the next line. And for you as a programmer, it feels like everything is running sequentially, but in the end, it's really here a message is sent to another actor. Your actor is going into the background, and at some point the other actor sends the reply back, and your canister comes back in the execution states and does something with the reply. Yeah, I mean, I've also talked about that, the orthogonal persistence model, that you don't have to care about how your data is persistent between calls. It's just there and very easy to work with. So a nice feature that is running, or a tool that is running on the IC itself, is the Motoko playground. So you can easily like open different example projects or import projects from GitHub, or of course write your own little project that you can explore and adapt in this Motoko playground that is running on the internet computer itself, and then deploy those smart contracts in Motoko on the internet computer itself, and just play around with it. So I think that that's a really cool learning experience, just to without setting up anything, to work a bit with Motoko, learn about the the syntax and semantics. And what you also see here, what's pretty nice, because we have this candid, it's also pretty easy from this candid to build like a small UI of every service that easily allows you to play with your canister. So that it's a generic way to create a UI for your canister. So I can now do something. I'm actually not sure what this program really does, but I can call the function generate with a natural number, choose a natural number, and then I will get some text back, and the text is this. So as I said, I don't really know what exactly this particular project does. But yeah, what we also see here, it's using cryptographic randomness. This is another important feature of the internet computer, because how it works with this chain key cryptography and the threshold BLS signatures during consensus, it allows to create true randomness that you can access in your canisters. So you can create lotteries and all these kind of things, because you really can access true randomness and not not only a block hash or something which other people have influence in. So now we've gone through a whole lot of things. So now I want to show you a bit how to set up your development environment and how you would start building an app. So the first step is that you download DFX, which is a command line tool that bundles all kinds of tools to create and compile canisters and deploy them either locally or on the internet computer. This is how you would install DFX. You can just check it out on internetcomputer.org. There is a link to that. And yeah, DFX comes basically with one local replica, so one instance of the internet computer node, and this allows you to deploy your canisters locally, play with them without any cost, of course. And at some point, when you want to share it with the world and deploy it on the internet computer itself, then it's also easy to deploy it from DFX there, and it allows you also to like call functions on your canisters the same way we've seen it manually with the Candid UI. You can also call every service every function that your canister provides through DFX. And what I want to point out here is that DFX has quite a nice help interface. So every command has extensive help text and shows you exactly what subcommands are there. So I spent lot of time typing in DFX some command -- help, and then I know again what I can do. So this is something to keep in mind. So when you run DFX help, you will see all those commands, and then we can also see like a subcommand. If we do DFX ledger help, it will show you like all the subcommands and what they need in here. So this is really handy and pretty cool. So after you've set up or after you have downloaded and installed DFX, you can create a new project either with DFX itself, with DFX new project, or there are different tools made by developers to make it easier to set up projects. So for example, Create IC is an interactive command line tool to specify, do I want a Motoko project, or do I want a Rust project? Do I want only a front end, or only a back end canister, or do I want to make a full stack application that also involves an asset canister that provides a front end? And there's also Create IC app, which has two cool features. So one is it allows you to create full stack starters for full stack applications using different frameworks. So you can have a React, Angular, Svelte, Vue, or I'm not sure, maybe there are more that you can decide. And it also bundles Connect to IC, which is a library that easily allows to integrate multiple forms of authentication providers and wallets. But this one creates a special folder structure and is a bit different than the other two. That's why now we'll do the create IC app. So I run npx create IC latest. Then it asks me how I should call. I want to call my project. I take my project. And then, as I said, you can either have a backend canister only, or you have an additional canister that serves your front end and therefore also the code, like the agent code that allows you to interact with your backend canister securely. No, we don't want to use internet identity. And then it run through everything, creates everything. See, want to spend a minute on looking into the structure that's getting created. It takes a bit. So now we have this project set up, and I go inside there, and let's open VS Code. So I hope this is good to see. So now we have set up a new project, and this is what you see. So in the top level, you have a few things, and the most important file is dfx.json. This is basically the manifest of your internet computer project. In there, you will see the canisters that are there. So we have a backend canister of type Motoko, and we have a front-end canister, which is of type assets, because it will serve like HTML, JavaScript, CSS stuff. And then it has also a part about networks. So at first you have only this like local deployment, but you can always then later set up the IC network here as well. Besides that, of course, important is the source directory, where you also see backend, backend canister, which has this simple, what's telling me here? It's a bit too big, can't see anything. So here you see a simple actor that basically has one function, one update function that takes a name and then prints out or returns hello name. So pretty simple hello world function, and a front end canister with a bit of HTML and JavaScript code. JavaScript code. So let's just do Now we need to start the local replica first. So we do dfx start background. Now, an internet computer replica is started in the background, and now we should be able to do dfx deploy. And now it's compiling these Motoko canisters down to WASM and deploys those canisters, creates and deploys those canisters on the local network. And then you get suggested two links basically. So here I can access the front end, but I can also access the same as we've seen in the Motoko playground, the Candid UI interface. So let's do that first. Oh, now it shows on a different screen. Can we fix that pretty quickly? So you see the Candid UI interface that provides just discrete function. And if we take the other link, that's not correct. something went wrong here. So it should show me the front end and not the candid UI. I'm actually not sure what happened here. So normally you see that this canister ID is the same one as here, and this is the canister for the candid UI, but not my actual front end canister. So this shouldn't happen, but it happens. So let's move on. Yeah, I've already shown you this. You can deploy your canisters locally by starting the local replica and then doing dfx deploy. And if you then want to deploy your canister on the internet computer, you need some cycles. So you can either buy some ICP and convert them to cycles, and there's documentation on internetcomputer.org to do that. But you can also visit faucet.dfinity.org, and it will go through a process how you can claim a cycles wallet with 20 trillion cycles, which is enough to do some good programming on the internet computer. And probably you will end up in a Discord channel to ask for cycles, and I will be there to hand you over a coupon to claim these free cycles. And if you have everything set up according to the cycles faucet, then it's really just only dfx deploy with this. It does actually need to -- network equals IC, and then it will just upload or deploy your canister on the real internet computer, and everyone on the world can access it. There's some additional libraries and tooling I want to make you aware of, but you can check it out later in the slides as well. So there are useful libraries for your front ends if you want to create full stack decentralized applications. The basic one that's always bundled is Agent.js, which handles basically the calls to the internet computer and does all the encoding and decoding and verifying of the signature of the IC. So with this single public key. Then there's IC.js, which are a few libraries that makes it easier to work with some canisters, some base canisters on the network nervous system. So for example, the ICP ledger and the governance canister and these kind of things. So there's useful libraries to work with those base canisters on the internet computer. And Connect to IC is this library that makes it easy to integrate different authentication providers and wallets into your applications. If you want to write applications that don't work in the browser, but you want to integrate other backend systems, or you want to write a native mobile applications, so there are different agent libraries in Rust, Python, Go, Dart, Java, and .NET, and of course Dart and Flutter allows to build mobile applications, and Java has support for Android applications. Here are the links for the canister development kits. So in Motoko, it's simple. In other programming languages, you need those CDKs. So there's in Rust, there's one from Dfinity and one from Psychedelic. And then what I mentioned you before, this project Hazel, which allows you to write your canisters in JavaScript or TypeScript. There's a good link, awesome Motoko, which lists a whole bunch of libraries. So if you want to do something special in Motoko, there's some chance you find that already someone has implemented here. there's a VS Code plugin for Motoko, which you'd want to check out. And just recently, one of the community developers implemented a Chrome extension, IC Inspector, that allows to inspect the calls to the internet computer and provides helpful information. So normally calls are encoded in Candid and in CBOR, and it's all gibberish for the human eye in the browser. But with this extension, you can really look into what's happening between your application and the internet computer. There are a bunch of authentication methods and wallets. So Plug is similar to MetaMask from this experience. Then NFID and internet identity are a pretty different authentication method on the internet computer that allows anonymous authentication. So every dApp, your user gets a new identifier, and it's hard for the applications to, or you can't be correlated across applications. So this is also pretty cool, and you can, you yourself don't need to keep like a private key secret. It uses web authentication in the background, so you can use your fingerprint or Face ID and these kind of things to authenticate to applications. And there are explorers that allow you to see the ledger state and also to see what canisters are out there and interact with them through Candid UI. So besides that, there's a lot to do now for you to explore the ecosystem a bit more. So we have a showcases page, which shows you all kinds of apps that are available on the IC. There are lots of code samples that you can just clone and look into and change. If you're an Ethereum developer, I've written a blog post about the IC for Ethereum devs, because there are many differences between those platforms. So this might be interesting for you to check out. And there are lots of like tutorials and videos on YouTube and the Motoko Bootcamp to get you up to speed in the lower level details. You should join the developer forum and Discord. So on every issue you might have, it's a good chance that someone on the developer forum has already asked that before. So, and it has a very good search function. So there's a really good chance that you find an answer there. And if not, ask your questions and we'll help you. And if you want to really dive deeper into how the internet computer works in the weeds, then I can recommend reading the white paper for geeks. So I think we only have a few minutes left. So are there any questions you want to ask me?
I think most of the questions that I got initially in the chat, they were answered while you were covering the session. But anyways, if you guys have any other questions, please share them in the chat section. Someone asked to link to the white paper. If you can share it, Dominic.
Yeah, I mean, I will share the link to this whole presentation where all these links are inside.
Yeah.
So I've shared it in the chat.
No worries. For people who are viewing us outside Zoom right now on YouTube and on Binance Live, this will be quickly shared on the Discord server, on the Lumos Metaverse Discord server. So if you've not joined yet already, make sure you do. All the resources related to this workshop will be shared there as well, if you've missed it out here. Someone is asking some of the use cases. What can we do with Motoko?
Yeah, I mean, it's a general purpose programming language. You can basically do anything. I would say a good start is looking at the sample applications that are there. That, of course, there are a few things you can only do on the IC. like this, having smart contracts that can sign transactions for other blockchain ecosystems or get true randomness and these kind of things. But in general, yeah, Motoko is just a programming language. It's just like Rust or whatever. You can essentially build anything you want.
I hope that answers the question.
So there's a question, can we use this on Windows? Yes, you need to use the WSL or it's called so the Linux subsystem.
Windows subsystem on Linux, yes.
So can you
explain more about orthogonal persistence?
Yeah, the idea of orthogonal persistence is that normally you as a developer have to care about getting data in memory and preserving it on disk, or in databases, and the databases then think about how the data is preserved, that it's there when you need it, but still preserved when basically your computer goes out or whatever. And the orthogonal persistence model, your data between calls, so when your canister is called at different times, the current data is just there and available, and you as a developer don't have to care about management of the data. You just have normal data structures, and it feels like everything is in memory all the time. And there's I can share that there is a good blog post of one of our engineers that explains orthogonal persistence in detail. So I'm not really the best person to explain the details of orthogonal persistence, I have to admit. So I can try to find it, but hit me with other question.
Yeah. I think there is a lot of questions related to beginners. So a lot of beginners are asking. One specifically by Samir is that how would you learn and build if you were starting as a beginner? Where should they start really?
Yeah, so one is like what I tried to do a bit, but with this special starter. So if you go to internetcomputer.org and you go to developer docs, there is a simple example to deploy this Hello World applications in 10 minutes. So you can follow that and play around with it and see like the basic functionality. And starting with that, I'd really look into those sample applications. So there's a better view on that. On the website, there are different examples. That there are ones from provided by Dfinity and also from the community. So you can just go in there, and in most cases, you also have an implementation in Motoko and an implementation in Rust. And so I would just go ahead, read the source code. There is often very good explanations attached to it. Run it yourself, play around with it a bit, take some parts of the Motoko, for example, and run it in the Motoko playground. And then you'll get a feeling for it. And of course, there's like on internetcomputer.org, there's then enough documentation also to cover the details. So if we go here to building on IC and then on canister development kits, so there are different sections if you're interested in Motoko. So there is like a huge documentation on all things Motoko.
That is actually quite niche. I mean, if someone wants to start from like the basics, this is, I think, the best resource out there to get started with.
Yeah, I'd agree.
I hope that answers a lot of like a beginner friendly questions. Like if you are someone who's just starting out in Web3 and if you want to start building on internet computer, I think the first step would be to come on documentations and also the Motoko playground to see like some of the projects in action, test it out yourself, play around with it, and then see what you can build out of it. So I think these two resources, make sure that you do check out internetcomputer.org. The links to which I'd share in the chat as well.
Mm-hmm. I see lots of questions about internships. There are internships available at Dfinity, but actually I don't know how the process works. But it's, I mean, we typically have internships for real low level like researchers and engineers that work on the system itself and not on the application level.
Got it.
And maybe one thing on a learning path that there's also on Udemy that there's a very famous course like a whole web development curriculum by Angela Wu, I think. And
Yeah.
it also covers the internet computer in a section. Unfortunately, there's on YouTube there's like a 3-hour preview on that, and to do the full course you need to pay the Udemy course. But there are many offers that make it pretty cheap to do it. So there you would have like a video tutorial curriculum that walks you through everything.
Got it. Thank you so much, Dominic. I think we are short on time. But if you do want to connect with Dominic or want to ask questions related to internet computer, you can definitely join our Discord server, the link to which I've already shared in the chat. Make sure that you do follow Lumos Labs for regular updates on the hackathon. If you've not yet registered for the hackathon, all you have to do is go to hack.lumoslabs.co and register and build your projects on the IC protocol, the Internet Computer blockchain, and cool projects and win out prizes. Do check out the hackathon website. You will get the idea on what amazing prizes we are giving out for cool projects that you will be building. So it's still not late. It's very early. Go ahead, register, and start building. With that, thank you so much, everyone, for attending the workshop. Thank you so much, Dominic, for taking on the time and explaining us Internet Computer. I am hoping that all of the attendees today have got an immense understanding of the fundamentals of Internet Computer and the Motoko programming language. And I'm very hopeful of seeing lots of projects being built on the Internet Computer. With that, thank you so much, everyone, for attending. Bye-bye for now.
Thank you. Bye.
Thank you.